Hello everyone, I am Anisha. Welcome all of you to my channel, that is Virtual Classes. So today in this class we are going to summarize your chapter number 4, that is the world of metals and non-metals. So we have already completed this chapter. If you haven't watched the detailed explanation of the chapter, kindly watch that, because in this class we are only going to revise, okay, and we are only going to see the important points, and these important points this will be very much useful for your exam, especially for your revision. Okay, so kindly watch the class till the end and also comment how do you find my classes. Okay, and don't forget to like, share and subscribe my channel. And today the class will be, the explanation will be in English. If you want to listen in Hindi explanation, the link is given in the description box, okay, or else you can find from my playlist. And this is for class 7 science, the world of metals and non-metals. So we have already completed the detailed explanation of the chapter, so we are going to revise the chapter here in today's class. So firstly, your story, this chapter actually starts from a story of Yashwant and Anandi. They were visiting a local ironsmith in Rajasthan to learn about some metal craftsmanship. Why? Because a project was been given, was been assigned to them by their school. So in order to learn about the craft person, they went to a craft person, okay, and they went along with their grandfather. So some common items they came to know, on going there they came to know that some common items made by ironsmiths were tawas, buckets, tongs, spades, axe, drawers and rakes. And when they started talking with the ironsmith there, whose name was Sudarshan, so they came to know that the iron, the material used, okay, was iron, mostly iron, for tools and woods for handle. Why this woods was being used for handle? Because see, if you are not making any if you are going to make the handle iron itself, then what will happen when while you are cooking, you will burn your hand, because in iron, which is a metal, heat transferred very fast, okay, conduction of heat happens very fast, and about which we have already learned in this chapter. So that is why a handle of wood or plastic, okay, can be used. And for heating, he said that he used coal. Why? Because heating makes iron red hot and easier to shape by hammering, and he was giving the desired shape by hammering after heating the iron in a iron, okay, and making it very red hot. On that condition, he started giving it shape by hammering, and you can see the image in your book also. All right, and leads into study of properties of material. So after learning about all these things, okay, Anandi and Yashwant, they this leads for them to learn about the property of materials, that is the metals and non-metals, okay. So firstly, we are going to see the properties of materials, especially for the metals, okay, malleability. This is the first property that we have learned. I hope you remember, and in this connection we have done an experiment also, isn't it, where we have collected some copper, aluminium, iron, nail, piece of coal, a pea-sized lump of sulfur and a block of wood, in order to check whether they are malleable or not malleable. And what does malleable mean? It means ability of material to be beaten into thin sheet without breaking, okay. Malleability means if a material can be beaten into a thin sheet without breaking it up, that means that material is malleable. And here what have we observed? We observed that all the metals, okay, the metals, for example, what metals that we have taken? We have taken aluminium, iron, piece of copper, isn't it? So all these came to be malleable, and the other item like the coal, lump of sulfur, block of wood, they were not malleable. And especially block of wood, it was neither malleable nor it was not brittle, as well as not malleable, okay. So metals like copper, aluminium and iron are lustrous, that means they have shine, and they are hard and they are malleable. So this was the observation that we have taken out from the experiment. And example, silver foil on sweets. Have you seen there are some silver foils on sweets, or gold foils are also there in some expensive sweets. So that means those, see, silver is also a metal. So if you can convert that small foils from the silver, that means it is very much malleable, Okay, so an aluminum foil also, the one which has been used to pack your lunch, especially your rotis, your chapatis. So that aluminum foil, it is also a metal which is made from aluminum. So it has been beaten into that thin sheet, isn't it? Not only beaten, it was made, okay, into that thin sheet through machine only. It is been made. I don't think that the aluminum foil is also been made by hammering it. Okay, it is not like that. It is made through machines. So it is possible to make into that thin sheet because it is what? It is malleable. Okay, and gold, especially the most malleable. Okay, gold is one of the most malleable metal that we can found in nature. So about this, that was our observation. And the non-metals like the coal, sulfur are brittle. That means it breaks easily. When you hammer them, it breaks. But wood is neither malleable nor brittle. Why? Because it neither break nor it was can be beaten into a thin sheet. That is why that was our observation, that metals are malleable and non-metals are not malleable. And some metals, for example sodium, potassium, okay, they are very soft. See here, it is said that metals like copper and aluminum are hard, but there are other metals which are, for example sodium and potassium, they are very much soft, okay, and that can be cut with a help of knife very easily. Okay, and mercury is the only liquid metal at room temperature which is inside a thermometer. I hope you have seen that. It is only liquid metal. Okay, this is the only liquid metal at room temperature, means in the normal temperature. So in this way we have what done, we have hammered the nails and we came to know that okay, these are malleable. So what was our conclusion? Metals are malleable and non-metals are not malleable. Next property is ductility. Okay, and ductility means ability to drawn into thin wires. That means when you are able to change the metal into a thin wire, specially used for electrical fittings. Okay, that means that is ductile. That means that metal is ductile, that material is ductile. Especially here, metals are ductile and non-metals are not ductile. Okay, so example, copper and aluminum wire for electrical use, steel ropes for heavy loads, and gold. See, even gold, 1 gram of gold can be stretched up to 2-kilometer wire. So it can be stretched very long, but gold are usually not used for electrical fittings. Only copper and aluminum wires are used. Okay, but because if you started using gold wires, it is very much expensive, so we are not using gold here. Okay, but gold is one of the most ductile metal that you can say. It can be even stretched to 2 kilometer. Only 1 gram of gold can be stretched up to 2 kilometer thin wire. Okay, and non-metals like coal and sulfur are not ductile because they cannot conduct electricity. Okay, they cannot conduct heat as well as electricity, which is also one of the property of these material. And next, what we have learned, next property was sonority. That means the ability of material to produce a ringing sound when stuck. So any material, if you drop them, okay, if there is a sound produced, especially the ringing sound, that means it is sonorous in nature. And the metals, they are all sonorous. Okay, metals are all sonorous. Example, bell, your ghungroos, your pile. Okay, and non-metals produce dull sound. And if you observe with non-metals, if you compare with non-metal, they produce a very dull sound. Okay, so here the another property, the third property of material, that is sonority, is that metal came to be sonorous and non-metals are not sonorous. Okay, now conduction of heat. So this was I was talking about metal conduct heat very well. That is copper, aluminum utensil. See, when you are cooking, especially on a utensil, steel utensil or copper utensil, what happens? It gets hot very fast, and if there is no handle, then what will happen? We used to take it out with the help of a cloth, isn't it? But usually there used to be handle, and that handle is made up of wood or plastic for that reason, so that our hand doesn't get burned. That means metal can conduct heat very easily. Okay, whereas wood is a poor conductor. That means wood is a poor conductor, that is why it is not hot, and hence it prevents our hand from burning, and that's why handles are made from it to prevent burns. Okay, here also we have conducted one experiment, if you remember. See, you open your book also. Okay, open your book also on the side, so that everything will be clear to you while we are doing this revision of these important points from your chapter. Okay, if you open up your book, it will be easier for you. See, if you see your book there, you can see that we have conducted one experiment here, that in a glass we have poured some hot water and we immersed one metal spoon and another wooden spoon, and what we came to observe, that we noticed that the metal spoon is hotter to touch than the wooden spoon. So heat transfer through material is called conduction. When this heat transfer through this material, what do we call? We call it conduction. Okay, and in metals, conduction of heat happens quickly as compared to non-metals. Alright, see here, this was the experiment I was talking about. Metal spoon, this is a metal spoon and this is a wooden spoon. Both of the wooden spoon and metal spoon are immersed in the same hot water in the same glass, but after some time when we touch, the metal spoon is more hotter than the wooden spoon. So what does this conclude? It concludes that metals transfer heat very easily, okay, very quickly. And next we have conduction of electricity. Again, in metal you will find that electric current flows very fast, okay, very quickly. Not only quickly, it flows through them, okay, it allows electricity to pass through them. That is why in an electric circuit, in your previous chapter when we have made that tester, what we have observed, that when we were keeping a metal spoon also, the bulb gets glowing, isn't it? So that means metals, that is copper and aluminum wire, are good conductor of electricity. And whereas when you are placing any non-metals like sulfur, coal or wood or nylon, you will not find the bulb glowing. That means they are poor conductor of electricity. That means what we have concluded here, metals are good conductor of heat as well as electricity, and non-metals are poor conductor of heat and electricity. Okay, I hope this is clear. And electrical tools have rubber, plastic insulators to prevent shock, okay, and when you see proper, when you observe electrical tools and all, okay, you'll find that all the electrical have covering of plastics. Why? Because they are insulator, they will act as an insulator and they will prevent us from electric shock. Otherwise what will happen, if an electrician is working a barefoot or not having any electrical tools covering with plastics or rubber, then he will get easily shocked, electric shock. Okay, so that is why we have often observed that electricians, when they are working with electrical fittings and all, they used to wear footwears, and it is often advisable to wear footwears also, okay, so that they can prevent from shock, electric shock. So that was about the property of materials, of metals and non-metals, which you have come to know. Okay, now we will see effect of air and water on metals, especially iron. So for this also, what we have done an experiment, like we have taken some iron nails, shining iron nails, and the shining iron nails, and 3 glass jars where we have filled one glass with the water, another glass with air only, and another glass with both air and water. And in that, what do we observe? We observe that iron develops brown deposit, that is rusting only when in contact with both air and water, that is moist air. If it is kept alone in air or alone in water, it doesn't get rust. And that is what we have concluded from our experiment that we have done. Isn't it? That is, in the glass A and glass B, the iron nails do not show any brown deposit, but in the glass C it shows iron deposit. Why? Because the moist air is responsible for the development of the brown deposit on object made of iron. Okay, and this brown deposit, what do you call it? The brown deposit is known as rusting. Okay, and one more thing here, and in rusting, see, corrosion of iron, costly damage in infrastructure. What happens when these rusting happens, okay, in object of iron or anything, okay? So gradual deterioration of this metal surface caused by air, water and other substances, known as what? Corrosion. Okay, gradually it has been damaged, and so many infrastructure have been damaged, and huge amount of money has been used to make them, okay, to again make them. And in order to prevent, what you need to do? You need to paint, oiling, greasing and galvanization, that means coating with zinc. Okay, and here there is a fascinating fact that about your Delhi iron pillar, isn't it? Ancient Indian metallurgy, that iron pillar of Delhi resist rust for over 1600 years. Why? Because which was been made during the time of Chandragupta II. Okay, and it is about 8 meter high, which is given in your book. All right, and it is it has been made in such a way that it resists rusting. It means a proper galvanization was been done there, coating was been done. That means it shows that how our ancient Indian metallurgy was advanced during that time. Also they know how to prevent rust on this iron pillar. Okay, so this was the experiment I was talking about. See, in a glass A, you will find only air, and in glass B only water. This oil is being kept here so that air doesn't contact with water, and here both air as well as water. Nail is half immersed in water and half in air. That means, and the lid is open here. Okay, that means, and rusting happens only in this case. That means rusting brown deposits happens only when it comes with contact with both air and water, that is moist air. Okay, so I hope that was clear. Now let us see effect of air and water on other metals. Okay, like on other metals here, what have we done? You have to open your book as well. Okay, we have done one experiment, that was burning of magnesium ribbon. So in air it produced magnesium oxide, and after burning it, we some white powder has been collected in the watch glass, which is basic in nature, which when we taste with this red litmus paper and blue litmus paper, what we came to know that its basic is, its nature is not basic, its nature is basic in nature. Okay, and usually metals are basic in nature and non-metals are acidic in nature. Okay, so metals generally forms basic oxide. Okay, that means their nature is always basic. And here, if you, when we are burning this magnesium ribbon, what we have observed, the flame is white in color, yes or no? And sodium, yes, this is another case. Wait, okay, the flame is white in color, it is not yellow like normally it used to be yellow, but here the magnesium ribbon flame is white in color, and that white powder has been collected on a watch glass, and after that magnesium oxide has been formed, and in that white powder we have added some water to make it moist, and when we test it in the red litmus paper and blue litmus paper, what do we find? We came to know that it is basic in nature. Okay, that means metals generally forms basic oxide, and sodium reacts vigorously with oxygen and water stored in kerosene to prevent reaction. So here another thing what we have learned is that sodium, which is also a metal, okay, sodium which is a metal, is stored in kerosene. Why? Because it reacts with oxygen and water, and a lot of heat is being generated in the reaction, so that in order to avoid that, it has been stored in kerosene. Okay, see, this is the burning of the magnesium ribbon. Here this image should have come earlier. It's okay. So that was the effect of air on other metal. Okay, now let us see substance that behave differently from metals in air and water. So under this, what we have done, we have again conducted one experiment where we have burned the sulfur, yes or no, in an deflagrating spoon, in a long spoon which we have made, and it has been the gas which has been formed after the burning of this sulfur, it has been trapped, it has been kept inside a glass jar, and that gas, after it mixed with water, we came to know that it has produced sulfur dioxide, isn't it? The burning sulfur in produce what? Sulfur dioxide, which dissolves in water to form sulfurous acid, and which is acidic in nature, and sulfur here is not metal. Okay, that is why you will find it is acidic in nature. And non-metals generally, these are the features of non-metals. Okay, they are soft, dull, they are neither malleable nor ductile. Okay, they are poor conductor of heat and electricity, and they form acidic oxide. Okay, they form acidic oxide and usually do not react with water, that is, they do not react with water. Okay, that is why again your phosphorus, okay, it is been stored in water, because otherwise in air it catches fire. So that is why phosphorus, as it is a non-metal, it is been stored in water. All right, it is given here. Example, phosphorus stored in water to prevent ignition. If this phosphorus has been exposed in air, in oxygen, what will happen? It started burning. So in order to prevent that, in order to prevent the ignition, it has been usually stored inside a water. Okay, so this was substance that behave differently from metal in air and water. The important points that you need to remember. You see the experiment, okay, which you have done, as I am also explaining you the experiment also now, but we have already done this in detail, okay, in your chapter. If you haven't watched that, I am insisting you to watch kindly that chapter first, and only after that you watch summary. Then it will be crystal clear to you everything, okay, and you'll understand more, and you'll thank me later. So, and elements, again here we came to know there an element was been told to us, isn't it? An element that is substance that cannot be broken down further into simpler substance. Okay, and metals and non-metals are subcategories of this element. Okay, and about this element you will learn more in your higher classes. And what was been given to us here, we have 118 elements known to us, both natural and synthetic. Okay, presently there are 118 elements, and these elements are the basic building block of all matter. Okay, and some are naturally occurring while some are artificially made in the laboratory, and we'll study more about this in your higher grades. Okay, so here what you need to understand, this both metals and non-metals are subcategories. Okay, one of the subcategories of what? Element. Okay, which cannot be further broken down into simpler substance. So, importance of non-metal. See, in this chapter what we have done, we have learned that like metals, we have learned about the properties of materials, especially the metals are ductile, they are sonorous, they are malleable, they are these, that, isn't it? They are good conductor of heat, they are good conductor of electricity, and we have learned that non-metals are poor conductor of heat and electricity, they are not ductile, they are neither not malleable. So, that doesn't mean that non-metals are not important. Non-metals are very much important, because see, oxygen is a non-metal, okay, and it is essential for breathing. If there is no oxygen, then what will happen? We will not be able to live, isn't it? So that is why these are some of the point which highlights the importance of non-metals also. All right, and carbon next, found in all life forms, protein, fats, carbohydrates, which is very much essential, and nitrogen, which has been used in fertilizers and that supports plant growth. So these are all non-metals which are very much useful in our everyday life. Next we have a chlorine, which used for water purification. So chlorine, it is also a non-metal commonly used in water purification. All right, and next we have iodine, like this iodine solution. Okay, an iodine solution, which is a non-metal, okay, is applied on wound and it is used as an antiseptic. So these are some of the importance of non-metal which has been shown to you. Okay, like if we compare the properties of metals and non-metals, it is completely opposite. Okay, that is why, like in this chapter, as we have learned about metals, you might feel that okay, metals are more important, but no, non-metals are equally important. Okay, so many metals and alloys are vital in industry. So there are so many metals and alloys, okay, which are very much important. Vital means very much important. Okay, in industries, technology, aerospace. Like in technology, if we talk about in atomic energy, such as zinc-chromium, or in aerospace we have your metal titanium. So they are very much useful and they are being used. Okay, and they are also recycled to reduce waste, and these all metals have been recycled to reduce waste, and so that they can contribute to sustainability. All right, so these were some of the important points that we have seen. Okay, now key difference between metals and non-metals. Okay, this you can write it down in your notebook properly so that you can remember, and this the question usually it will come in your exam, okay, for 5 marks or for 3 marks. This is very important. So see, in property, if we talk about lustrous, metals are lustrous, that means they are shiny, and non-metals, they are not lustrous mostly. Okay, and malleability, metals are malleable, that is what we have learned, and non-metals are not malleable. We have all proved through this our experiment. Okay, and ductility, yes, metals are ductile, but non-metals are not ductile, that means you cannot stretch them, isn't it? Next, sonority, if we talk about the sound, the ringing sound, metals are sonorous, non-metals are not sonorous. And conductivity, metals are both good conductor of heat as well as electricity, and here non-metals are poor conductor of heat and electricity. And oxide, metal produce basic oxide, okay, which is basic in nature, and here non-metal produce acidic oxide, which is acidic in nature. And reaction in water, metals sometimes react, sometimes don't, but here mostly they do not react. That is why phosphorus was been stored in water, so that it can prevent the ignition. Okay, so with this we have completed the summary of your chapter, the world of metals and non-metals. Kindly comment me how do you find my class. Okay, and in our next class we will do with your textual questions, your extra question and answer, your important question and answer which can be asked in your exam, fill in the blanks, objective types, everything. Okay, so don't forget to subscribe my channel and share my channel with your friends. I really need your support now, kindly help me. Okay, and your comments motivates me a lot, so kindly don't forget to comment down also. Okay, thank you everyone for watching. All of you have a very nice day ahead. Bye.